So in this video, we're going to learn how to add and subtract rational expressions. But let's just first recap or review how to add fractions. So when you have, for example, 1 over 2, 1 over 2 plus, let's just say 2 over 3, when you add fractions, you need a common denominator, which is, in this case, give me a number that can go into 2 and 3, and that would be 6, the lowest. Okay, and then whatever you do to the bottom, so in this case 2 tripled to become a 6, so therefore 1 needs to also triple to become a 1. This doubled, so therefore the numerator also has to double, that becomes a 4. Then once you have a common denominator of a 6, then you just add the numerator. Now let's do another example. 1 over 2 plus 3 over 4. Now in this case, the lowest common denominator may not be the multiplication, the product between 2 and 4. For 6, we got 6 from 2 times 3, but in this case, 2 times 4 is 8, but 8 is a common denominator, but it's not the lowest. Now, the lowest number that 2 and 4 can go into is 4. 4 can go into 4 one time, whereas 2 can go into 4 twice. So basically, 2 doubles, so therefore 1 has to double. Whereas this fraction here, it stays the same. So now you can just add the two numbers. So what happens when there is variables in the denominator? For example, if you had 1 over 2x plus, for example, 3 over 4. Now, the obstacle right now is we need to figure out the common denominator. So in this slide, we're going to look for the lowest common multiple, or when we do fractions, it's called lowest common denominator. So let's just say you had this as your number term in your denominator. So to find the LCD, or in this case LCM, you look at 4 and 5. What number can 4 and 5 go into? The lowest common multiple, in this case 20. Okay, so the coefficients are still the same as it was before to find the LCD. Now, when we look at the variables, they both have an x, so the common thing they have is the x, all right? But the question is, what's the largest x value that both terms can go into? And in most cases, in all cases, you go to the one with the largest degree. In this case, the largest degree between these two terms is going to be 3. So in the next one, we have 4 and 5, which is the same thing. The LCD is 20 for the coefficient. But if you notice in this case, they both don't have a common variable. They're both different. So when they're two different things, you're just going to put them together, x and y. You just multiply them together. It's sort of like finding the lowest common multiple between 2 and 3. 2 times 3 will give you 6 as the LCM. The next one is 2 and 4. So we know the LCD is going to be, or LCM is going to be 4. It's not 8 because we can get a smaller LCD. Now in this case, this has no variable, whereas this one has a variable. So what you're going to do is you take the one with the variable. Over here, there is no coefficient. Well, it's actually 1, so it's a 1. I don't need to put the 1, but it's there anyways. So now both terms have both x and y. And we always go for the one that has the highest exponent, highest degree. You have x squared, x3. We're going to take the x3. In this case, we have y4, y1. We can take the highest one, which is y to the 4. Now in this one here, we have two binomials, and they have nothing in common as a whole in itself. They're not exactly the same. So this is very similar to finding the LCD between, for example, x and y. So to find the LCM between these two different looking terms, it ends up being x and y, xy. So this is very similar. So when you want to find the LCM, we just bring these two terms, or two binomials, together. So now we're going to add a rational expression where the denominator is all different and it has variables. So to find the LCD, we're going to have to look at 4, 6, and 8, and the lowest common denominator is going to be 24. Now all of these three terms has an x, so your LCD should have an x, but how much? What's the degree of your x? In this case, we go for the highest degree, which is a 3. So next step, I'm just going to write down the 3 fractions, but I'm going to have 24x3, 24x cubed, 24x cubed in each case. So now we're going to have to change the numerator, because the numerator cannot stay the same because we're changing the denominator. So you ask yourself, what number did you multiply to get from 8 to 24? Well, we're going to have to triple, so times 3. And if you look at the x squared to a x3, well, how much more do you have to multiply to get you that degree difference? So x squared times what will give you x3? In this case, it's going to be an x. So what that means is you're going to take your numerator and multiply by 3x, which becomes 9x. You do the same for this second fraction here. What number from 4 to 24? You're going to multiply times 6 and x. You have a single x here, but you have a 3x's here. So you're going to have to multiply by x with a difference of 2. You need to compensate for that. So now you're going to take the 1 and change it. How are you going to change it? You're going to multiply by 6x squared, which is 6x squared. You do exactly the same thing for here. 6 and 24, you're going to have to quadruple this. And you look at the x cubed, there is no change, so we don't have to multiply anything in terms of variables. So all you have to do is change the 5, quadruple, gives you 20. And at the end, you have 24x3, common denominator, just put it under one single denominator, and you just add the terms. Now, if you look at these terms, they're not exactly like terms, so you're just going to leave them as it is. You don't have to simplify them because you can't. And the last step is, let's put things in highest to lowest degree. And then you're done the question. Now, before we actually end this question, we need to talk about restrictions. So restrictions, like the previous videos, we look at each individual denominator, and we don't want those denominators to equal to 0. In all cases, 8x squared cannot equal to 0. You work it out, you end up getting x is not equal to 0. If you do the same for all two of them, they'll pretty much be the same. So in this particular example, we have a denominator where it's a binomial. So I'm going to just put a bracket around here just to show them it's one entity, one binomial term. Now, before we actually start doing the adding, let's do the restrictions first in this case, unlike the last one. So we set each denominator to not equal to 0. Do the same thing. And then n cannot be equals to 3. You bring the 1 over or subtract both sides by -1, and you divide both sides by 2, and you get 1/2 negative. So these two numbers are the restrictions. Now let's add them. So if you notice these two pieces, they don't look the same. So the LCD would be just to bring them together. Take the product of the two together. So what I'm going to do right now is make lots of room, because you're going to have a large fraction here, a large rational expression here. So I'm going to write down the common denominator, LCD, and I'm going to write down 3n. And then you need to ask yourself, well, what has changed? Well, what has changed is this 2n plus 1 has a new factor. So in other words, you actually took this piece and multiplied both by n minus 3. So in other words, I'm going to have to insert the brand new factor. This one over here, I have a 4. Then what is that brand new piece of your denominator from here to here? Well, it is this 2n minus 1. So you're pretty much compensating, multiplying top and bottom by the binomial that it didn't have before. So now we have everything over the same denominator. And then I'm just going to bring them together really quickly. And you're almost done the question. The last thing is simplifying, to simplify the brackets out. So we're going to distribute, and you end up getting 3n squared minus 9 plus 8n plus 4 all over 2n plus 1 over n minus 3. And at the end, now you can collect like terms, because these two both have an n, gives you 1n plus 4 all over 2n plus 1 and n minus 3. And I believe that you are done the question. Now sometimes, if you notice the numerator, this is a quadratic. Now sometimes you may need to factor using either decomposition or whatever way that you learn to factor. In this case, I know for a fact you cannot factor, so that means you can't go on. So sometimes the fraction here, the rational fractions, can be simplified if you can factor. Something can happen. So here we have a higher degree in the denominator. It's a quadratic. And when you have quadratics, in a lot of cases, you may have to factor the denominator. So let's start to factor this. When you find restrictions, it's always in the best best interest to factor. In this case, the difference of squares, we have a minus. When you have a subtraction sign, you have to be very careful. We'll talk about that why in a second. A minus 1 and a plus 2. I'm going to put a bracket around here. Okay, so let's do the restrictions first. Each piece contributes. In this case, the first piece, in this case, a cannot be 1. This one here, a cannot be -1. This piece here, a cannot be -4. This one's the same thing as this piece, so you don't really have to write the fourth one because it's going to be the same thing as the first one. This is your restrictions. Okay, so let's actually erase this piece here. Okay, so now you look at the denominator. What do they have in common? Oh, okay, they have a minus 1, a minus 1. But what do they not have in common? Oh, this one doesn't have an a plus 4. This one doesn't have an a plus 1. So your LCD is going to be the following. Keep the one that's in common and write down the rest that's not in common, a plus 4. Okay, so we're going to put this, it's going to be a little bit more space. Okay, so you have a minus 1, a plus 1, and a plus 4, because this one doesn't have a plus 4. This one is a plus 4, a minus 1, and then you need to compensate for the one that it doesn't have, which is a plus 1. I'm just going to write down 2a bracket a plus 2. Now the next piece is you're going to have to figure out the difference. So in this case, a minus 1, a plus 1, yes, yes, but it doesn't have an a plus 4, so we're going to have to compensate it with an a plus 4, or multiply it with a plus 4. In this case, a plus 4, a minus 1, yes, yes, it doesn't have an a plus 1, so you're going to compensate with what it didn't have before, a plus 1. Now let's put this all under one ginormous LCD, and in this case, I'm going to directly, since I have no more space left, let's see, I'm going to expand this, distribute this, so that becomes 2a squared plus 8a minus. Now in this case here, we'll do the brackets first. We're going to have to do a times a times 1, 2 times a, and 2 times 1. So I'll do that, and you have to put a bracket, because if you don't put the bracket, the signs are going to be all off. So a squared plus, I'm just going to like cheat a little bit. I'm just going to just simplify it right away, and you end up getting this eventually. If you didn't put the bracket, what's going to happen is that all your signs will be the opposite. Will be incorrect. So now that we have this negative here, we're going to have to distribute this inside. All the signs in here are going to be opposite. In this case, 8a, so this is a negative 1a squared. The positive becomes a negative 3a and negative 2 all over a minus 1, a plus. It's a long question. All right, so let's actually collect like terms really quickly. You have a squared plus 5a and then minus 2 all over this. And I know that I cannot factor this numerator, so I stop my question here. Now, if you didn't put a bracket around here, let's just erase this thing here. And what's going to happen is that you're not going to get the same thing as we had before. That means all your signs are off. Over here, let's put a there, a squared. In this case, if you did it this way, you end up getting something different. You get up this one plus 11a and plus 2, which is very different from this one here. So here's our last example. Now, if we look at the denominator, they kind of look the same. Well, they're kind of the same because this is a positive x, this is a negative x, this is negative 3, this is a positive 3. So the signs seem to be opposite. If the signs are opposite, what you can do is you can factor out the negative 1 from one of them. I'll factor out the negative 1 from here. So if I take a negative 1 out, what happens? I get negative 3 plus x. In other words, it's the same thing. Over here, negative 1, x minus 3. If you notice, now you have a common denominator. But what about this negative 1? Well, this negative 1 is actually multiplying with a positive in front. So a negative and a positive will become a negative. So you have 5 over x minus 3 minus 2 over x minus 3. So now, in this case, we do not need to find a LCD because it's already the same. You just subtract your numerator, 5 minus 2, which is 3. And in our case, we should have found the restrictions. The restrictions don't change. It's going to be x cannot equal to 3. If you don't believe me, x minus 3 cannot be 0. 3 minus x cannot be 0. X cannot be 3. And if you bring that x over, 3 cannot be x. It's the same thing.